Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at podcastinit.com/Linode and get a $20 credit to try out their fast and reliable Linux virtual servers for running your app. And now you can deliver your work to your users even faster with the newly upgraded 200 gigabit network in all of their data centers. If you're tired of cobbling together your deployment pipeline, then it's time to try out GoCD, the open source continuous delivery platform built by the people at ThoughtWorks who wrote the book about it. With GoCD, you get complete visibility into the lifecycle of your software from one location. To download it now, go to podcastinit.com/GoCD. Professional support and enterprise plugins are available for added peace of mind. You can visit the site at podcastinit.com to subscribe to the show, sign up for the newsletter, and read the show notes. And if you have any questions, comments, or suggestions, I would love to hear them. Your host, as usual, is Tobias Macy, and today I'm interviewing Ruud van der Ham about Salabim, a Python library for conducting discrete event simulations. So, Ruud, could you start by introducing yourself?
Yes, thank you very much for inviting me in the show. Well, I started my working life as an operations research engineer particularly in the port industry in Rotterdam. I'm from Holland, and I had a long working experience in that field. And I particularly did a lot of work in the field of simulations. It's also this is actually the subject of this podcast, I think. And I retired a couple of years ago, and I live now in the south of France. And I'm still active as a consultant in the field of container terminal automation and all that. And besides that, I'm a quite active Python developer, particularly in this package we're going to discuss today.
And do you remember how you first got introduced to Python?
Yes. Actually, that all happened something 2 years ago, I think. I have a good friend of mine who works for the Dutch Railways, and he pointed me in the direction of Python. And I have a very long experience with all kinds of other languages. I've started actually with, everyone in my generation, more or less with BASIC, with Algol on big mainframes, and did all the languages you can imagine. Assembler, did a lot of Assembler, Pascal, PL1, and all that. But my friend actually said, well, Python is such a nice language. So I had a look at it. And at first I found it a rather strange language, particularly this indentation business of pointing out the structure of the program. But after a while, I got to understand it, and I found it really a great language, and never regretted in going into this direction. And now Python is really my language, although still I use from time to time for specific tasks some BASIC, particularly for extending Excel.
And so the Salabim package that you've been working on is for doing modeling of discrete event simulations. So I'm wondering if you can explain a bit about what that term means and how the Salabim package helps with performing that modeling.
Yes. Discrete event simulation is actually a technique from the field of operations research, and it tries to simulate, to model processes, and that whole is particularly industrial processes and logistic processes and all that. Actually, if you just look at the term discrete event simulation, you see the term discrete. And why is that discrete? There's also another simulation type, which are continuous simulations. And that's another field, actually. That it involves differential equations and all that. And that's not the field I'm working at. Although there are some ideas on extended. Maybe we'll come to that later. Event simulation. Well, events actually means that you skip from time to time. So what there actually is, there's also always the concept of time. We have processes, and those processes have a certain timeline, and they interact with each other, and that's where the event comes into the picture. So we simulate actually from a certain time moment to the next moment. And what differentiates that from, for instance, real-time programming is that time step is done in real time, time zero. So you actually skip from one event to the other one. And if there's let's say, in simulation time, an hour between those events, you don't have to wait for that hour. You just skip just in the processing time, or just one step with the program. You step from 1 hour to the other one, and then maybe a minute later something else happens, and then you just step for that 1 minute. So you see a kind of stepping on the timeline, which is not uniform at all. So sometimes there's an hour, sometimes a couple of seconds, sometimes there are even maybe hundreds of events at one moment, and that's where those events come into. And now, what can Salabim do with that? Well, this technique actually started more or less in the late 70s. There was a simulation language called Simulabim. That was the first object-oriented language ever. And that language had already elements in it to perform those discrete event simulations. And what does that mean? Actually, we now call that coroutines usually, and that means that you can have a process running separately from another process, and you just have a mechanism to synchronize those things. That's similar language was developed, and the basis of that is still the basis of a number of other packages, and Salabim is one of them. So Salabim actually supports terms like hold and activate and passivate. So you can passivate a process, and that means that the process just waits for an outside signal, kind of trigger mechanism, and that's the basis of the Salabim package, actually. And so by making a model, describe actually the system you want to simulate, you can translate that into Python code, and then you can just run it, and then you get your results. So that is how Salabim can help running simulations.
And can you explain a bit about how you chose the name for the package?
Yeah, that's yes, of course. Well, Salabim is actually, maybe the listeners know, is one of the magic words. The magic words Sim Salabim. So Sim Salabim, and Sims then is actually short for simulation. So that's actually the connection, and it's just nice, a nice word, and didn't exist in any other package. So I thought that's a good thing. So what you can, and actually what I do usually in my simulation models and all the sample programs I've made, I always start with import Salabim as sim. So there you can actually see the connection as well.
It's always great when there's a bit of humor connected with these different packages that people put out. It's one of the great things about the Python community as a whole, is that sense of whimsy that's just sort of built into the community.
Yes, that's true.
And so I'm wondering if you can talk a bit about what your motivation was for creating Salabim in the first place, and how it compares with other tools that are available for performing discrete event simulation, whether that's within Python or within other languages.
Yes, I can do that. Well, as I explained earlier, I'm a consultant in the field of simulations, and in the past I did a lot of programming as well. And nowadays I still do a lot of consultancy in that field, actually, just guiding simulation studies. And those simulation studies are mainly always done in rather big proprietary simulation packages, and those are really those fully contained. They're based on a kind of languages, but it's a lot of click and point and click systems, and they're highly advanced. They are extremely nice visualizations from time to time, but there's a there are a couple of disadvantages of those packages. First of all, they're extremely expensive. You have to think about prices like 10 to 100K, and that even doesn't include hundreds of users. So they're very expensive. And the second thing is that they're good for a certain type of applications in a certain field. For instance, if you want to do warehouses or something like that, they might be extremely good at that. But if you want to do a little bit more different than the usual algorithms that are integrated in the package, you're more or less stuck. There are all kind of decisions made in the package already. And if you want to do something else, those packages usually have a kind of escape routes. They support C++ subroutines or Java subroutines or something like that. But then all of a sudden, this very nice framework that they offer isn't that nice anymore at all, because then you have to interface with with those visual elements and all that. It is not clear at all. So I work a lot with people who are using those packages, but I also wanted to do maybe go a little bit back to my roots to do a little bit of modeling myself. And then I started looking, and I had already implemented once a similar package in Pascal, and I was looking how can I do that. And well, that was the time that my friends came along with, who pointed me into the direction of Python, and I started looking, and I found a discrete event simulation package in Python. It's a package called SIMPI, and this is SIMPI, because there's also the symbolic package SIMPI with a Y, but this is a different package. And that actually more or less did what I wanted. And there was an older version 1 and 2, and then they upgraded to a version 3. And all of a sudden they had other implementations. They didn't use the words I was used to, like hold and passivate and activate. They had terms like events, triggers, and all that. So quite different. And I didn't find really at ease with that. So I started actually building a kind of layer around it, and I could do more or less what I wanted to do, but it wasn't very elegant, and I did want to build another feature, and that was not available, and I had to extend it. And then I thought, well, if I really look at it, I can also do it myself, and that opened the possibility for me to do more to structure it more the way I wanted it, and to add many more features, because this SIMPI package, the first version, was very nice, and they had a lot of features in it. But at a certain time, the developers decided to take a lot of functionality out of the package, because they said, well, that's also available on other services. But in practice, at least not in my opinion, that doesn't really work that way. So I really wanted to have something more. So I started developing my own package. And in the beginning, it was a rather simple thing. It could just perform the event simulation and all that. But I got more and more involved in what Python could do. And as a side project, I had also done already quite a lot of creative animation in Python, and kind of figures that can just move and all that. And then I found that I just found actually that those two techniques could be brought together. So then I start building an animation on top of it, and that was not available in that other package at all. And that really is an enormous advantage, because now I can just visualize my models. You can see objects moving and machines working and vehicles running and all that. And that's actually what it made quite different from this SIMPI package. While looking at other systems, there are other packages like this in other languages. There's a Julia implementation of SIMPI as well, and there's an R implementation of kind of similar thing. So there are some other packages, but I'm very familiar with Python, and I love the infrastructure and all that. And well, maybe we come to that later. The only disadvantage is the execution speed, maybe, which is definitely not the same as you could reach, for instance, in Julia or in Go. But so far for my project, it's okay. But that might be a problem in the future.
And while I was reading through some of the documentation for Salabim and a bit about the concept of discrete event simulation, I was struck by the fact that it seems fairly similar, at least in some elements, to the idea of state machines. So I'm wondering if there's any overlap in the sort of use cases for a package such as Salabim and a state machine library.
Yeah, well, I'm not extremely familiar with state machines. I know a little bit about the background of it. What's important in simulation is event simulation. That the time aspect is extremely important. And as far as I know, state machines doesn't really support that mechanism. Of course, the state of what we call components are stored all the time, and we skip from state to state and all that. But I don't really have any experience with state machines. But I've just looked at it, and what's definitely possible is to simulate state machines with Salabim, because that's just going from one state to another, and that's also definitely possible. But I think the type of applications are quite different. But as I said, I don't have that much experience with state machines myself, actually.
And how is Salabim implemented under the covers? And I'm wondering how the overall design of the package has evolved over the time that you've been working on it.
Yes. Well, Salabim is implemented as one package, actually. It's at this moment still one single file, and it runs under all versions of, well, the normal versions of Python, including 2.7. Well, I first started simple, and then I added the animation features, and then I added quite a lot of other functionalities. One of the most important things is what I call monitors. Monitors is actually following the state of, well, we have something called the state in Salabim, but also a very important aspect of these simulation packages in Salabim as well is queues. Components, that's one of the main elements. Maybe Python people might use the word object, but I want to differentiate that from Python object. Can be in queues and can be in many queues at the same time. And those queues are usually very important to collect statistics about. And with Salabim, there's an automatic monitoring system. So every time there's a state change, for instance, a component enters queues or leave a queue or something like that, or state changes, that's all monitored. And then you can just, at any point of time, you can request the statistical information about it. It's extremely powerful. I added also a lot of statistical distributions in simulation. Statistical sampling is extremely important. You usually just define properties as a statistical distribution. So, for instance, you say a time between arrivals of clients in the system is, the term exponential distributed. And you can just say that sample from an exponential distribution. But I've included many more other distributions. And over time, as I say, I started the development something late 2016, and then it was still, well, it worked, but that was all, and made it much more Pythonic over the last year, and now I think it's rather nicely structured, and I use a lot of the facilities of Python now. For instance, I have my own queuing system. Of course, you have in Python, you have lists and tuples and decks and all that. But for sublimation purposes, it's much nicer to have some more facilities, particularly for the data collection and all that. And quite often also components just enter in a queue just somewhere relative to another component and all that. That's all supported. But in the beginning, I had to say things like queue.length and as an attribute. But of course, Python also supports those structures like len. So now you can just say len of a structure, and you can just go through the queue by saying for component in queue and all that. And it really looks very nice, and also very compact code, of course, by implementing it that way.
And I understand that the majority of the development that you've done on the package has actually been written on an iPad. So I'm wondering if you can speak to why you chose that as your development environment and what your experience has been working in that environment.
It's a little bit weird, maybe, but and I really just switch between the two systems, between a Windows environment and an iPad all the time. And the reason I started is actually that I started actually my animations on the iPad, so I did a lot of work in there, and so the animation engine actually just worked in the beginning. Only worked on an iPad actually, because it's quite different structure and they have good facilities for that and all that. And then I started the Windows implementation, or the CPython implementation. But then still, I found it's really very easy to develop on an iPad, because it's so simple. You have it always on you. You can just take it in the train or in a plane or whatever, and it's so extremely simple. And the environment, the development environment of this implementation on the iPad is really fantastic. You have all facilities, including debugging and good IDE and all that. So I feel very at ease with that environment, actually. But, well, the development is actually more or less split. So from time to time, I do some work on my iPad, and then go switch back to an ordinary IDE on a desktop system. And particularly if I want to do some bulk editing, like replacing and all that, it's quite usually much easier on a proper IDE, actually, with a keyboard and all that. But still, I do quite a lot of work on the iPad, actually, just because it's so convenient to me, and it also makes the code maybe better because I have to maintain two environments, and that makes me think much more about what's the best structure and all that, so the way it's built actually is I have two different animation engines which come together, and in the beginning they were quite different. So I had a lot of code specific for the iPad and a lot of code specific for ordinary CPython implementations. But I found that actually in the iPad I had some things that I couldn't do, and I found also some things on the CPython platform which I couldn't do. And then I escaped to a more common base in doing all the animation. Actually, all the animation pictures are actually now made in Pillow, the Python image library. And the Python image library is now just the basis of all my animations. The engine on which I run on the CPython platform is tkinter. So I use the canvas of tkinter for my animations. But tkinter doesn't support, for instance, rotating of strings, text strings, and that's quite a hindrance, because sometimes you want to have to put a string under an angle for certain purposes. So that was something what you couldn't do. And on an iOS system, on the iPad, I couldn't actually do a filled polygon. But on the Pillow, that's all available. So I do all the preparations now in Pillow, and then just present it, and that's. It's definitely something possibly I would never thought of when I just did my work on the desktop.
And for somebody who wants to use Salabim to create a simulation, I'm wondering what the workflow looks like for being able to actually model the different components of the system and then actually create a visualization from that, and then what the output from the simulation would look like and how they might use that for validating the system that they're trying to perform a simulation on.
Well, what's extremely important in simulation modeling is first of all to have an idea of the system you want to simulate. You have to model because the real life system is usually far too complicated to put every aspect in. So you have to make some ideas, to have an idea on what you put in the model, how far you want to go, and all that. For instance, in my field of container terminals, what I've done a lot of work in, if you want to simulate a container terminal, you can go into every detail in the movement of wheels and every of the equipment and ships with their mooring and all that. But it all depends on the question you want to answer. If you're only interested in the capacity of cranes, for instance, well, maybe you can just omit the arrival of trucks and maybe even of the ships and all that. So you have to make a model in your mind, and usually you can just go further in a later stage, but usually the best is to start a little bit on a high level, and then you go and describe the different processes. Well, as I said before, we have the word component, and component is actually the main structure of the main element of a simulation. So maybe I can just describe a little bit about on how I would model, for instance, a post office where clients arrive. So we have the post office. There's a clerk, I suppose. Maybe there are even more clerks behind the counter, and we have the clients coming in. And let's say that's all we want to model. We don't have to go and model every detail, the doors when the door open and all that, but they just enter the system. Well, obviously, in this case, we have the clients as components. There's quite likely, and that depends a little bit on your modeling, but we might also have the clerks as a component. And the clients have to be generated. So usually you model it, then we have a client generator, and the client generator is actually the driving force behind the whole simulation. That's built as a class in Python terms. There's a class client generator, which is subclassed from a Salabim class called components. So it's class component. And the client generator, well, what does it have to do? It has to generate the client over time. So, and it has to do it all the time. So we just say while true, and all the time generate a client. Client is a new one, so we make a new component there. If we say something like client is client or something like that, and then we have to wait for a certain time, and here comes in the real discrete event simulation terminology. Then we actually, in the process of the client generator, it has a special procedure, special methods that's actually generated. We say yield hold, and the yield hold that just says that give control back to the event mechanism, and then something else can happen. So we say yield hold, and then we sample from a certain distribution. Let's say we sample from a uniform distribution between, let's say, 2 and 10 minutes. So every between 2 and 10 minutes, a client arrives. So we just say yield from a sample between 2 and 10, and that's the end of this process. That's all, because then there's the while loop. So then after this, let's say we sample five minutes. After 5 minutes, the client generator becomes active again, and then it starts up. What I said, I've made a client, and the client automatically starts its own process. And the client has a process, and the client will have a process like it looks for, is there any clerk available? And if so, activate that clerk. And if not, just go and passivate. And that's actual. And then after that's the main structure of this the client. And the clerk is actually also quite easy one, because the clerk's actually doing all the time, because the clerk has to work, of course, all the time. The clerk has a while loop around it, so it's a while true. And it always says, is there a client waiting is there a client waiting? Is there a client in the queue? And so if there's a client in the waiting line, it says, it picks up the client. Does it work? So it holds for a certain amount. This is again that same yield. It holds for a certain time. Let's say between 3 and 5 minutes or something like that. That's the real processing. And then after that time, it just says activate the client, and the client was actually just passivated. And then by activating that client, the client knows, okay, I'm done. And that's the end of the client, and the client just automatically disappears then. And what you can do with this type of modeling already, as I said, there's a queue, a waiting line. You can just ask for the statistic on the queuing line. How long? What was the average queuing time? What was the maximum and all that? You can see it in time and all those things. We usually do present it as a histogram, or you can just feed it into to more sophisticated packages like Matplotlib or something like that, and visualize it properly. And so then you can get all the information. You can see the occupancy of the clerks, and all that. And so I've described now those three components: the client, clerk, and the client generator. And all you have to do is you have to start it, because there's a mechanism. The mechanism starts. So just at the main program is just say run for a certain time. You say, for instance, run for a day, for 24 hours, and then the whole mechanism just starts via those yields, those coroutines actually, and then you get the system running, and then after that one day you can just collect your information. But this is rather static. You can trace those things. If you put a trace on, you get a kind of dump where you can actually see, okay, this is the client generator generates something, and the clerk does something, and it goes into queue and leaves the queue and all that, and you see that on a timeline, and that's excellent for debugging and all that. But of course, you can't really see it in time, and that's where animation comes in the field. And in this case, that's really extremely easy, because there's just a facility to animate queues. So if you just say animate this queue, this waiting line, you can see immediately the waiting line getting longer and shorter and all that. You can even see which clients there are and all that. And you hardly have to program anything to see that. That's a simple type of animation actually. If you just want to have a block rectangle for a client. Of course, that's not always enough. Sometimes you need vehicles running or cranes moving and all that, and then you have to do more, and then you have to go into make your own animation objects. And the basics are actually rather simple. The Salabim supports a couple of basic structures, and it's not a lot actually. We can do rectangles, lines, polygons, text, circles, images, and those objects can be moved over time. So what you can actually say, okay, we are now, let's say it's now time 10, and I want to have that rectangle, which is it's a red rectangle, and I want to move that to another coordinate, and to arrive there at time t is 20. And those times are usually, of course, connected to the simulation time. And then all this movement is done automatically by the system. The user doesn't have to do anything like that. And you can change all the attributes of the component over time. So, for instance, you can change the color. You can say, okay, at time 10 it's red, and at time 20 it's blue, and it just automatically goes from red to blue. As the angle, the rotation, the size, all those things, line width, and all that can be all changed over time. It's a little bit overkill for most animation, for most simulations, but it's all available in the package. And so Well, for complicated animations, you have to do quite a lot of coding, but it's you can make very very nice animations with that.
For people who are interested in doing these different event simulations, I'm wondering if there's a point at which the capabilities of Salabim are not sufficient, and whether you have any suggestions of the types of tooling that people might be able to use in those situations.
Yes, yes. Well, first of all, let me state that Salabim is only an option, I think, for people who have abilities to program. It's not for the end users. And a lot of the nowadays the simulation developers are not really programmers anymore. So if on the team there are no people who can do or want to do that type of program, it's not the right package. And then the next step where it might not be not perform is really if the problem becomes too big, and particularly in processing power. I mean, and well, that has to do with the fact, of course, that Python is definitely not the fastest language in the world, and then you might get into trouble. So far, in my experience, it still worked okay. If that doesn't work, well, Python, you can still use Salabim actually with PyPy, which is really excellent. I've done a number of experiments, and I found that under PyPy, my models run something like 7 times faster than under normal interpreted interpreted versions. So it's a very nice performance. And actually, there's another package which is quite popular that runs under Delphi, and I've done some benchmarks again, Salabim with PyPy compared to this, well, considered quite performing package, and I find that it's only twice slower than that other package. So that's not too bad. Well, if Salabim doesn't work anymore, you have to escape to more sophisticated packages that can run on multiprocessors and all that. And that's something I don't support, and I don't think I'm going in that direction in going to those really high-end simulations. So then you have to really escape to other packages, and maybe to those very expensive packages that are on the market.
And what have you found to be the most complicated or difficult aspects of building and maintaining Salabim?
Yes, it has to do with the integration of animation and simulation. Simulation has its own timeline, and the animation has its own time frame. And to synchronize those things is not really easy, and that was quite complicated to realize. And I also spent quite a lot of time on thinking of what kind of graphic engine I would like to use under to animate the processes. And I had already some experience with Pygame. And that is not too bad actually, but this is some of the features I wanted actually. And then I looked at PyQt, but PyQt has the disadvantage of it's quite big package, and I didn't want to have my users install all that. So I went into tkinter, which is okay. I don't consider it a great package, but it works for me. And so the design was really something quite complicated. As I said before, I use PIL, the Python image library, and that's a nice package, I must say, but also has some peculiar things. There are even some bugs in it which I have to program around, which was not always that obvious. Well, just in general, the API design, what kind of calls, how would I like to interface with it, was not obvious to me in the beginning, and I've changed actually that quite a few times. It's now rather stable, actually, I must say. So that was something. I really wanted to have compatibility with Python 2.7, and that gave me some trouble. But now I have the same code base for all the Python versions. And recently, that was quite interesting and quite a technical challenge actually. In my tracing, I wanted actually also to trace the line numbers of the code where I was in. So now you can see in the trace, you can see exactly at what line a process is and where it's activated from and all that. And I had the idea to do that. I had to look into the code for that, and there's a very nice module, the inspect module, is part of the standard library, I think, and that gave me the option to program this functionality. It is not always that obvious. And another thing, but more or less a design consideration actually, I wanted to keep the dependencies as low as possible. So in the beginning, I had, for instance, NumPy in my imports, but now I've just phased that out. So there are hardly any dependencies, only tkinter but tkinter standard and pillow, the PIL. That's actually the main dependencies I have, and we haven't touched that item yet, but maybe nice to talk about that as well. The animation can be also outputted to a video, so you can make an MP4 video, and that's done straight into Salabim. So you can just say video is, and you get the file name, and then you get a nice MP4 video out of it. And in the beginning, I just made a bunch of JPEG pictures, and then with FFmpeg, I just combined them. But now there's also OpenCV, also called CV2, and I just include that in my dependencies, and then you can just record a video, which is excellent for communication with people somewhere else. Of course, it's a very nice feature, this OpenCV. And if you don't do any video productions, you don't have to include that OpenCV at all. So it's nice and clean. You hardly need any other libraries for that. And then talking about the difficulties and the challenges is particularly the documentation. As you know, the developers, well, the developer, they don't really like the documentation. Of course, it's important if you want to have some other users. Well, I found the doc strings rather good, so I rely on the doc strings very much, but there's more you need, of course. So I've developed now a pretty expensive set of documentation in Sphinx, but to get all that up and running, it's not all obvious, and it's also not my favorite work. So still hope to have some other people going to work on that to help me with that.
And are there any new features or particular improvements that you are planning to include in future releases of Salabim?
Yes. Well, first of all, I want to make the animation a little bit easier to interface with. There are still some rather complicated calls you have to do, but I think there are some other possibilities. And one other thing, it's one of my users actually in the community who suggested that and have done some experience with that already. He is apparently trying to, or has implemented, I'm not really sure of the state of that, integrating it with Blender, this 3D animation engine. And that might be really great if we could do the output in 3D, full 3D and all that. So I'm definitely going to look into that, whether that could be an addition, maybe an extension in some way. But that's really on my radar for the next month. Further, I still consider making some continuous simulations, so doing differential equations as well. I'm working together or in contact with a Belgian chap who had made something similar in Julia, and so I'm looking at whether I could maybe use some of that technology as well in Python. And other improvements, I'm still looking at other user interfaces. Maybe WX Python is a possibility, and to offer some more facilities for that. And definitely in the future, I want to improve my manual and have some more tutorial material available for new and current users.
And are there any other topics that you think we should talk about before we start to close out the show?
Well, we didn't really actually talk about what type of applications this type of modeling can be used for. Very typical applications are I mentioned already ports, where I'm very, very familiar with, but also warehouses, distribution networks. You see a lot of implementation on airports, both for the passenger flows and for luggage handling systems, gate control, and all those kind of things. I've seen a lot of applications in hospital logistics for distributing medical material, but even for the operation theater and all that, how to operate that. Really a lot of applications, mainly always the generic term that combines them all is logistics together. And then what's necessary to realize that simulation as such is never a real production engine. So that exists, but it's quite rare. So it's really a research tool. And when do we need it as a research tool? Particularly for dimensioning problems. How big would the fleet size be? What's the optimal speed of vehicles? How do you lay out a warehouse? What type of cranes would you install and all that? So that all has to do all with the resources and how many and how fast and all that. And then also the control of those things. What kind of algorithms can you use to control the resources? So decision logic, in other words. One example in my field is, for instance, if a container comes into the port, where do you store it? You can store it nearby, but then it's in the way for other containers, or you can store it far away, but then you need the equipment and all that. So quite complicated algorithms you have to design. It has to be implemented later in the production system. And for that type of problems, simulation is also extremely useful. And so, in other words, just most of the time before you implement a new system or invest in a new system, or just to redesign systems by implementing new algorithms and all that.
Yeah, it definitely seems like a very useful package for being able to perform the simulations for the sort of logistics problem domain or capacity planning. So I can see a lot of value that people can gain from that. So for anybody who wants to get in touch with you or follow the work that you're doing, I'll have you add your preferred contact information to the show notes. And so with that, I'm going to move us into the picks. And this week I'm going to choose a coffee grinder that I got recently. It's a burr mill grinder, so it gives a nice consistency of the grounds. And it's proven quite pleasant to be able to just walk into my kitchen in the morning, hit the button on how much coffee grounds I want, and just walk away to get the water started. So for anybody who's in the market for a new grinder, I'll add the one that I got. It's Cuisinart. It's relatively inexpensive compared to some of the other options on the market, which can go up to the hundreds of dollars if you're so inclined. This one was in the sub $100 range, so pretty happy with the quality for the price. And so with that, I'll pass it to you, Ruud. Do you have any picks for us this week?
Yes, I have some. First of all, I want to mention Pythonista. Pythonista is one of them, but in my view, the only good implementation of Python on iOS. And it's really an excellent package. It includes an IDE, and it's compatible with Python 2.7 and 3.6. Supports things like NumPy, unfortunately not TK Inter, but it's an excellent package. There's a very lively community around it, and I can really recommend that. For me, it would be just a reason to buy an iPad actually, because on Android systems there isn't anything uh, comparable available at all. So really recommend it. And then I had just two books on my list. There's one, I think it's only available as an ebook. It's Python Notes for Professionals. It's a free book. It's over 700 pages of very nicely presented material on Python. It covers more or less the whole language. It seems to be composed of Stack Overflow articles, but nicely presented and all that, and it's free, so just have a look at it. And this is not really new, but I just looked at my bookshelf, and I can only recommend the book Fluent Python by Luciano. And it's a super book, and it covers quite advanced Python, everything you will need. And even if you've read it already once or twice, then if you pick it up next time, like I do from time to time, I always find some new things, and it's really recommended.
All right. Well, I appreciate you taking the time out of your day to join me and discuss the work that you've been doing with Salabim. Definitely looks like an interesting package that's solving a useful problem for a lot of people. So I appreciate the time that you've put into that, and I hope you enjoy the rest of your day.
Thank you very much, and I hope the listeners have enjoyed it.